once we know what the problem we are solving, it is all about reducing the error rate. And we have seen tremendous progress in the world of AI in the last few years in reducing the error. And there are three key dimensions here. One is data. If you can increase the size and quality of data that you're using, certainly error can come down. If you can increase compute or improve the quality of the technique, you can also reduce error. And now what we're seeing is that it's a multiplicative effect of these three. And in fact, what you're beginning to see is that once you increase compute and data and techniques, the error rates just plummet. And nowadays there's a trade-off. In fact, in some cases, for example, Google has shown that if data sizes are small, for example, in natural language translation for the languages that are not very well spoken, for those, if you just increase the compute, you can get a similar accuracy. So it has become a multiplicative thing: compute, data, and technique. Now let's go a little bit into data. First thing here is about more sensors. And we have seen that the moment we increase the number of things that we're measuring, we can do in industrial examples. For example, we have seen predictive maintenance saving millions and hundreds of millions of dollars if we add more sensors and start measuring. But it's not just about manufacturing. In every industry, you can see that by sensorization, you can actually collect more data and improve techniques. We've also seen alternate data. For example, in Theramin, which is our AI-driven investing business, we have seen that if you actually start looking at data like parking lot data to see the earnings performance of a retailer, or you look at the earnings conference call data and look at the voice tonality of the CEO and the CFO, or if you look at satellite pictures to understand crop yields, you can actually get this alternate data which gives you a new signal that improves the overall quality of decision making and overall reduce the overall error rate. The third and fourth dimensions here is about synthetic data and experimentation. Nowadays, you're seeing a rise of synthetic data. And one of the things we have noticed is you can use synthetic data to build the models, but I always recommend that you use actual data to validate the results. And finally, experimentation. The more you explore, the more you have budgets to explore, you can create new data because the feedback that you get from the experimentation is actually new data. And there you can improve the quality of the models. Coming to compute, you're seeing a rise of cloud computing. And one of the reasons we could actually deliver to the Mumbai and the Karnataka and the Telangana governments is because we could set up a very flexible system in literally 24 hours. All of this could be set up in 24 hours. We are working in a very hyper agile mode, but still we could do this in 24 hours and start producing really important outputs in 3 days. It's because of the rise of cloud computing. And we are living in this very important era of computing where the compute loads have just gone through the roof. It's exponentially increased in the last 2 to 3 years, especially with higher parameterization of models and so on. But compute has become cheaper and compute has become abundant, and everybody is raising the level of compute in their own organizations. We've also seen that while compute is going up, we also have these cases for edge computing or fog computing. And how do you do that? I mean, for example, in Mumbai, we were trying to understand using cameras and drone cameras. We were trying to assess where is social distancing compliance being met or not met. This is one of the solutions that we built for Mumbai police as well. And one more example is in Africa, where we're deploying TB solutions. And we realized that there's simply no internet connection. So we created Cure in a box. So everything on this box, there's GPUs, all the decisions. You just plug this box in and you can have an X-ray AI algorithm detecting tuberculosis and so on. So this is another example of edge computing. And the last point here is about about quantum computing. You've seen Google declaring quantum supremacy in 2019. This is very early days, but in the next few years, quantum computing promises to be something extraordinary because it can really reduce the complexity and the order of computation of very complex problems from exponential time to polynomial time. So this promises to be an extremely important area of technology to invest in. So this is about compute, but the last point I want to mention here is custom AI hardware. You're seeing rise of ARM and other kinds of methodologies, tensor processing units, and so on, which is also increasing the compute. From a technique standpoint, we had used structural models. We used the basic spread understanding of the disease, and because of which our models gave through some results which are extraordinary. I mean, they were bizarre because when we saw the numbers, I couldn't believe that India would have those many cases. But India ended up getting 11 million cases, and our models were actually right. because not only were we using ML, we were using the structural understanding of the disease spread, and that really improved. What we are seeing again and again is that if you have a causal understanding or a structural understanding, there is a lot of reason to believe that you can improve the overall performance and reduce error rates. And there are better techniques too. And deep learning, while it is extremely popular right now, it's not clear that deep learning is going to be the future, right? There are so many new competitors for deep learning. And eventually, we know that better techniques are going to come through. And you're seeing rise of transformers as a technique, or GANs, or other kinds of new learning, deep reinforcement learning, and so on, which are also promising to be the panacea for better techniques and for stronger AI. And the last point here is about federated. There's a privacy, the continuous learning of models is another area which is growing a lot. For example, federated learning, where it is privacy preserving, but each device in itself learns a little bit, sends the update in a privacy preserving way. And you can see that that kind of a technology is also going to become more and more useful. And any continuous learning system also will actually reduce the error.